All right, in notes 1, our introduction to statistics, basically, we start off with some vocabulary, and I won't sit here and read the entire thing to you, but I do want to give you a basic knowledge of it. Data are the observations or measurements that we collect. Statistics is the process of collecting, organizing, summarizing, analyzing, and drawing conclusions from data. There are 2 types of statistics, and we'll go through those in just a little bit. Population is the entire or full set that you want to be able to say something about. A sample is a subset of the population. So if I were to talk about the entire population of students at South Plains College, that is a population, the entire 10,000 students plus. That is our population. If we talk about just the students in this classroom, that is a sample of that population. A census is a collection of data from every member of the population. And I'll discuss that more in class. Census is when you're actually able to collect something from every member. Voluntary response is a sample in which respondents decide whether or not to be included. So like if you are in the mall and somebody walks up to you and asks you a question, you absolutely have the opportunity to decline or to participate in those studies. Statistical significance is a result that is unlikely to occur by chance. A parameter. Now, these two vocabulary words are really important in that if you're talking about a parameter, it's a numerical value that has something to do, or that describes a particular aspect of the population. If you're talking about a statistic, which is what we hear more, it is actually something that's based on a sample. So if you're able to perform a census, right, and get a statistic, that is called a parameter because it involves the entire population. Population parameter, sample, statistic. All right, 2 types of data. There are quantitative data and there are qualitative or categorical data. The quantitative data is numerical. And I'll let you read through the definition. Those are kind of important. It gives you some examples and everything. Now, this quantitative data has 2 sub categories as well. One is discrete data and one is continuous. All right. Discrete data is data that is countable. So like the number of pencils in your bag, that's countable. The number of students in my nursing math class, that is countable. The number of male students in your classroom, countable. Those are examples of discrete data. Continuous data are data that have to be measured. Now, there are lots of different things that have to be measured, but for us, most of them have to do with weight, height, length, so like a distance would be one, temperature, and blood pressure even. Okay, things like that that are measured. Those are examples of continuous data. Now remember, those are subcategories of quantitative data, which are our numerical values. Now, if we have data that is not numerical, and so that's how I'm going to distinguish that from qualitative, these are non-numerical or categorical. So non-numerical, excuse the handwriting. These are data that are observed and not measured. They are categories: blue, colors, your majors, political affiliation, religious affiliation, anything like that. Things that are not numerical. All right. Now, here's a really short little example, and in the video, I'll just tell you the answer is letter D. I'll let you go through it. In class, we'll actually describe and show you why. 4 variable levels of measurement. The first one is nominal. Nominal data, and again, these are the 4 levels of measurement. Nominal data is categorical and have no rank or order. Now, these next two definitions actually apply to all of the levels of measure, but I'm going to define them here. Mutually exclusive means that each piece of data fits into only one class. Exhaustive means all data fit somewhere or fit in some class. So there isn't going to be a need to add anything. We build it so that every piece of data falls into a particular class, and every piece of data falls into only one class. That is, those are requirements for all of these levels of measurement. Now, for examples of nominal data, they have to be categories that do not have any order or rank. Some examples of that: political affiliation. That's an A. Religion. Colors. This is going to be interesting. Social security numbers, and we'll talk about why. Even your ID numbers. You're like, wait, Miss Lopez, those are numbers. Not really. Even zip codes. And we'll describe why in class. Let me give you an example of, we'll pick one. In class, we actually go through and describe all of them. On this one, nominal is categorical data that has no order or rank. Okay, political affiliation, let's do religion. I don't want to get in trouble. Okay, so religion. It doesn't matter what religion you are. There is no way to order them because the number one is going to be yours, right? Well, they're like, at least 100 different religions, and there is no way to order or rank them. So that's why that type of categorical data is considered nominal. Another type of categorical data is ordinal. But ordinal data that is categorical can be ordered. So examples of those types that can be ordered: what about the months of the year? Yeah, they go in order January through December. How about the sizes like small, medium, and large? See, categories, but they can be ordered. What about your letter grades? Yeah, they're orderable. All right, now let's look at two more levels of measurement. The first one is interval. It is numerical. So now we're looking at data that is numerical. This first one has no meaningful zero, and then ratio is also numerical, but it has a meaningful zero. So let's talk about examples of each one of those. No meaningful zero. I think the easiest example there is temperature. 0 degrees Fahrenheit doesn't mean that there is no heat. That is just that label on that scale. And if you think about it, that is true, because if you convert it to Celsius degrees, that is a completely different number. Okay, so those are just labels. There is not a meaningful zero. Another example would be, let me see, I can't think of an IQ. And again, we'll talk about that one in class. Now, another level of measurement, or our fourth one, is ratio. This one has a meaningful zero. Now, every one of us has the same number one example: money. Does it mean something when you have zero in a bank account? Yes. Okay, anything that has to do with amounts. Amount of gas in my car, amount of money in my bank account. Okay, all of those things that are considered to have a meaningful zero are considered ratio level data. And the interval are those that have no meaningful zero. And in class, we'll come up with some more examples together. All right, before we go on to the next video, I do want to go ahead and talk about the two types of statistics. Above, we kind of defined the process of statistics, but they're actually two levels, or two types. The main one, descriptive statistics, is what we're going to spend most of our time on. And then the second one, inferential statistics. All right, and just a basic definition, we'll go into it a little further in class, is descriptive statistics is all the charts, the graphs, the percentages, the tables that you see. That's descriptive statistics. Inferential statistics is using that to make predictions. So like people who predict who's going to be in the Super Bowl, I have a real interesting story about that. You'll hear it in class. But inferential statistics is where you use data that you collect to make predictions. Okay, like sports analyst. All right, well, I'll see you in the next video. We'll finish up notes number 1.